The last packet capture technique we're going to talk about is called ARP Cache Poisoning, and it's really one of the neater ways to collect packets because it doesn't rely on any specific hardware. You don't have to have a hub or a tap or a switch with a specific capability to do this. It's an entirely software-based attack, and it essentially works by way of deception. We're actually manipulating the expected behavior of the address resolution protocol, the ARP protocol, to trick devices into thinking they're communicating with the device they're not communicating with. Now, this only works within a network, so it doesn't work across the internet, but it does work within a network in most cases. And we're not going to go in depth here and talk about ARP. We have a dedicated lecture on ARP later. And we also have a dedicated lecture on security later. We're actually going to go through and dissect the packets involved in ARP cache poisoning and what that looks like from the packet analyst perspective. That said, this lecture is really more about helping you collect packets. So we're just going to talk about this now kind of from the broad sense, tell you a little bit about how it works, and then show you how to do it. I'm actually going to provide a demo here in a minute using the Cain Enable tool for Windows and show you how to intercept packets using the ARP cache poisoning technique. Now, if you look at this, the image I have on the screen, we have two traffic patterns here. On the left, we have a normal traffic pattern, and on the right, we have the traffic pattern associated with a poisoned ARP cache. Now, we've talked a little bit about network addresses and layer 2 addresses, so MAC addresses. So computers and network devices generally need to be aware of both of those. They need to be aware of layer 2 addresses for communication within a network and layer 3 addresses for communication outside the network. And they use the ARP protocol to kind of associate those. When we say address resolution protocol, it's the process of resolving IP addresses and MAC addresses and relating those together. Now, the target computer and router, both in this scenario, are the devices whose communication we want to intercept. So we have our sniffer here, and it wants to intercept everything between the target computer and the router, which is essentially saying it wants to intercept all of the inbound and outbound communication to the internet from the target computer. So we're trying to see what's going on with that device, who it's talking to, what the nature of that traffic is, maybe trying to troubleshoot something or doing a penetration test or something of that nature. Now, with the normal traffic flow, the target computer is talking directly to the router, and of course that's going through a switch. Now, with a poison ARP cache, it's a little bit different. The sniffer in this case is going to send out specially crafted ARP packets designed to trick the target computer and the router into thinking that it is the other communication partner. So it's going to send ARP packets to the target computer saying it is the router by way of having its MAC address. It's gonna say that its MAC address belongs to the sniffer, and it's going to send ARP packets to the router saying that it is the target computer. So, of course, when the target computer and the router think they're talking with each other, they're actually going to be talking with the sniffer. And the sniffer, to some degree, is going to act like a router. It's going to route the traffic back and forth between the systems. Maybe better to say it's going to act more like a switch. It's going to act like a switch and relay that traffic back and forth and pass it back and forth between the target and the router. Again, the idea here is we're intercepting traffic between two devices without actually being physically in between them. We're just taking advantage of an inherent design flaw in the ARP protocol that allows us to trick the target into thinking that the sniffer is the router and trick the router into thinking that the sniffer is the target computer. So pretty neat. Again, don't worry too much about the details now. We have a dedicated lecture on this later, but just understand that this is a software-based approach that allows us to intercept packets without any of the headaches that we get from some of the other methods. So this method is really useful in a couple of ways. Number one, like I said, it doesn't require any hardware. So if you can't afford any or you just don't have any available, that makes this a bit easier. Furthermore, it's another technique you can use when you can't install things on the target system, or maybe can't unplug the user. It's a way to get around that. It's particularly useful in penetration tests. I mean, this is called ARP Cache Poisoning, which doesn't sound like a very pleasant name, and that's because this is an attack method. This is a method attackers use to intercept traffic from systems. I mean, if you're ever sitting in a coffee shop and there's a good chance maybe you're susceptible to an attack like this. This is the type of attack someone would use to maybe do some password stealing or steal cookies and do an impersonation attack and access a website as though they are you. So it is an attack. It's a form of a man-in-the-middle attack. So it's very useful in a penetration testing environment as well, since it is an actual attack. And now it is nice that an attack can be used for good as well, because ideally we're going to be using this for good and capturing packets for which we have permission to capture those packets, of course. Now, this technique is not useful in a couple ways. One is that it, for at least a little bit, will disrupt live communication. So there is a point in time where communication will switch over, where the target and router are no longer directly talking to each other, and they're talking to the sniffer machine, and that could abruptly break some active communication and cause some connections to die, depending upon what network, what software you're using and what you're doing. For instance, if you're watching a YouTube video and it's not buffered too far ahead, and you enable ARP cache poisoning, start that process, you may cause the user to have to refresh or something like that. So that's just one example, but that can cause some problems, and it can disrupt a little bit of live communication. The next thing has to do with certificate chains and HTTPS or SSL communication. I'm not going to go too in depth right here on certificate chains, but ultimately, this does break that process a little bit, and you have to deliver self-signed certs and things like that. So if there's, if users are browsing to HTTPS websites, they will get the message in many cases that the certificate that's being passed to them is not a properly signed certificate, and that can tip users off to the fact that this is going on. If this is normal and the user knows this is happening, that's not a big deal. But if you are doing this in a penetration test, that might tip them off that something's going on. So that's something to be concerned about there. And finally, some switches will actually detect this activity and block your port. So if a single device sends out multiple ARP packets claiming to have a specific MAC address tied to one single device, and the switch observes this, some switches will actually detect this and detect this as an ARP cache poisoning attack and potentially block the port and disable your sniffer's access. So this is a configurable thing on most of these devices, so you can actually turn it off or disable it for a short period of time and work around it. But it can cause some problems. So overall, the guidance here is that ARP cache poisoning is great in a pinch. It's a great way to get around not having to have hardware or unplugging a device. But you have to really handle it with care. I don't really recommend doing this on really, really important production systems. It can cause some unintended effects. And also be careful doing this on high throughput systems. If you attempt to ARP cache poison a system plugged into a gigabit link and you're on a 100 meg link, you could very easily saturate your connection and drop packets, and also at that point adversely affect the performance of the device that you're whose traffic you're poisoning. After all, at that point you are essentially becoming a switch for that device, so you become a bottleneck as well, and that has to be something that has to be considered. If you're intercepting the traffic of a system and you start doing something very processor intensive on your system, you're going to slow that other system down, and that's something you have to be aware of. So ARP cache poisoning is a great technique. I do use it from time to time when it's not acceptable to unplug another system, or I need to do something very quickly and don't have time to, maybe don't have access to a port mirror or can't do a tap or something like that. So it is a nice trick to have in your tool bag. And now we'll take a look at that, and I'll actually show you a demo of how that might work. So now, just like we did with port mirroring, I want to give you an example of what it looks like to actually go through the process of ARP cache poisoning. It's definitely one of those examples that makes a little bit more sense when you actually see it in action. Now in this case, I've got 3 windows set up, and we're looking at a scenario not too much different than the port mirroring scenario. On the top right, I have a device on my network pinging out over the internet to 8.8.8.8, just sending a repetitive ping over and over again indefinitely. At the bottom right, I have Wireshark open, and Wireshark is actually capturing packets on my local machine. So it's actually capturing just the traffic it sees here locally. And I've got a display filter applied so that it'll only show the ICMP data it's capturing. Of course, it's actively capturing now, and you see that there's no data available, which means it's not seeing the traffic that's being initiated from this other machine on my network. We're not seeing that traffic. So how can we see it? Well, we're going to ARP cache poison to do that. Now, downloaded Cane Enable here, which is a tool that has a lot of uses. It's mainly designed as either a defensive testing tool or an offensive tool, depending on your perspective, and it does a whole lot of different things. But one of the things I like it for is its ability to do ARP cache poisoning and redirect traffic for packet capture in this way. It's a Windows tool. It's quite old. It's been around for a long time. I think I wrote about it in the first edition of Practical Packet Analysis over 10 years ago, but it still works really well and has a lot of great features. So if it isn't broke, don't fix it. Of course, there are a lot of other tools you could use for this job, but I like Cache. It's very easy, so we'll just show it here, and it's really great for demonstrating this in action. Now, I'm on the sniffer tab here, and the first thing I really have to do is activate the sniffer and understand the host that exists on my network. And to do that, you'll see that one was picked up passively. I'm going to go ahead and tell it to scan MAC addresses here, and it's actually going to scan all the MAC addresses in my subnet and build a list of those out. That process happens very quickly here, and you see we have a lot of different hosts available to us. Now, in this case, the host I'm particularly interested in, the host that I want to intercept its traffic, is this 10.2.2.30 device. That's a device that's non-local, so it's not the device you're actually seeing me sniffing traffic from now, but is the device you're seeing me initiate this ping from. I'm just connected to that device via SSH. So that's the device whose traffic I want to intercept from my host. To do that, we're going to switch over to the APR tab, which is our ARP poisoning section. To set up this capability, I'm going to click the plus, and I'm going to go ahead and tell it the devices I want to sniff. Remember, we're sniffing communication between two devices, right? We're not just sniffing the device, we're sniffing the communication between devices. In this case, I'm interested in 10.2.2.30, and I'm also interested in anything going between it and the internet. Now, to get to the internet, it has to go through my local router, which is 10.2.2.1. So I'm saying here, basically, start capturing the communication between 10.2.2.30 and 10.2.2.1. Again, we're using ARP to accomplish this. We're sending ARP packets that trick both of these hosts into thinking that my intermediate host is the other one. So 10.2.2.30 thinks I'm 10.2.2.1, and 10.2.2.1 thinks I'm 10.2.2.30. So it's essentially a man-in-the-middle attack, so to speak, that allows us to capture these packets. So I've set that up. I've clicked OK. Now pay attention to this Wireshark window here, because I'm going to hit this button up here, which is going to enable it, this little radioactive symbol. I'm going to click that button. It's going to give me a little error message I'm going to ignore. And sure enough, what do you know, the second I click that, we see that the ICMP traffic above is now going through my host. So I'm essentially actively performing this man-in-the-middle attack. You see that Cache enable provides a routing table here, which is actually going to show some of the hosts that are being sniffed. In this case, we see the communication between 10.2.2.30 and 8.8.8.8. Looks like 12 packets one direction, 54 packets the other direction. And of course, this is all reflected in Wireshark as well. If there were any other communication going on between 10.2.30 and the internet, it would also show up here as well. But it's just this one stream of communication, so that's all that shows up. And really, ARP cache poisoning is as simple as that. I can stop the communication by clicking this radioactive symbol again, and it's going to pause that. You'll see the status goes to idle, and I'm no longer accepting that traffic. So in this case, this is a great example of how to use ARP cache poisoning, how easy it can be. Again, lots of tools to do this. This is our Cache, which is a Windows-based tool. There are Linux-based tools. And you can even actually do this yourself. Later in the course, I'm going to go through an example of ARP cache poisoning from the defender's perspective. So what this looks like, all the ARP traffic, how you can recognize that someone may be ARP cache poisoning you. We're going to look at it from that perspective too, which is useful as well. But this has been just a quick example of how to perform ARP cache poisoning on your network if you need to actually intercept the packets of an individual host.